Here are the formulas that define what we mean by standard deviation. For the population standard deviation, we start with x minus mu. That means the difference between the data value and the mean. We square it to make it positive, then we add all those up. Remember that Greek letter sigma means add these things up. Then we divide by the number of data values to get the average, and then we undo the fact that we squared things by square rooting the whole thing. Now, those of you that are pretty good with algebra will realize this isn't quite going to give us the answer we got before, but still, it's close and it's the same idea. Now, there's one more wrinkle, and that is if you're working with a sample, the standard deviation S, and notice we use the Greek letter for the population parameter. That's kind of a theme in statistics notation, and we use the English letter S for the statistic. Parameter is a number that describes a population, and a statistic is a number that describes a sample. Anyway, we're going to do the same thing. We're going to divide by x minus the mean, except that a sample mean is called x bar, not mu. We square it to make it positive. We add them up. But the weird thing about the sample standard deviation is we divide by n minus 1. We divide by a number that's 1 less than the number of data values, and then square root. An important key point here is that the larger the standard deviation, the more spread out the data value is. Now, these computations are a bit complicated, so it's kind of nice to have a table to organize what you're doing. For example, let's find the standard deviation of the population data set 1, 3, 5, 6, 7, 8. So in my table, my first column is going to be my x values, which are 1, 3, 5, 6, 7, 8. Then I'm going to record what x minus mu is. Of course, to get that, I need to know what mu is. So in the last row of the first column, I'm going to record the sum of the x values. That sum is 30. So I know that mu is 30 over 6, which is 5. By the way, I don't know if I made it clear that n in our formulas is the number of data values. And since there's 1, 2, 3, 4, 5, 6, n in this case is 6. Okay, I'm ready to record my x minus mu's now. The x minus mu's that I'm talking about come from the formula where we have x minus mu. We have to compute all the x minus mu's, then square them, then add them up. That's the first step in using this formula. So let's find all our x minus mu's. The first x is 1, mu is 5. 1 minus 5 is negative 4. The next x is 3. 3 minus 5 is negative 2. 5 minus 5 is 0. 6 minus 5 is 1. 7 minus 5 is 2. 8 minus 5 is 3. Now I need to square all those x minus mu's. So let's label ourselves an x minus mu squared column. Negative 4 squared is 16. Negative 2 squared is 4. Then we have 0, 1, 4, and 9. Now we have to add those up. So the sum of our x minus mu squareds is 34. What does the formula want us to do next? Let's take a look. We're using the population standard deviation formula because our numbers represent a population. So the next thing I need to do is divide by n. After I divide by n, we'll take the square root of the whole thing. So our standard deviation for the population, again, we're using the formula sum of the x minus mu squareds over n, and then we take the square root. The sum of our x minus mu squares was 34. N is still 6, like it was when we were computing the average. So 34 divided by 6, which is 5.66 repeating 6. And then just leave that number in your calculator. Don't round it off, because if you round off before you get to the final answer, that introduces more errors. So I've got these 5-point repeating 6s on my calculator. And I'm not rounding off. I'm just going to hit the square root button. And I get 2.38. We'll round off to the hundredths place. Let's just compare that out of interest to the average deviation from the mean that we computed when we were getting the conceptual idea. And we got 2. So 2.38, it's not exactly 2, but it's in that vicinity. The standard deviation is an approximation of the average amount by which data values differ from the mean. Why do we use this instead of that? Well, as I said before, there's technical reasons that are beyond the scope of this class to get into.